Hi guys, hope you all are fine and doing good. So this is Javed Akhtar, and I am before you with a very simple module on applied probability and statistics. I personally think that when it comes to learning, there are two perspectives: whether I am learning to build a car or whether I am learning to ride a car, right? And this perspective makes all the difference. So usually when we try to learn probability theory, it comes with a lot of theories, theorems, and maths. And usually a learner gets boxed down because of that, right? So in this module, I have tried to simplify things as much as possible. And I hope you guys learn from this, enjoy this. And if you do really enjoy this, please like and share my LinkedIn page and YouTube channel. Uh, But before I proceed further, I want to clarify one thing. That is, this video is not part of any commercial or non-commercial campaign, but very my own initiative. To give something back to the society in whatever form possible. So, with that in mind, let's start. So, before I begin, let's focus on who are the audience set for this. Okay, for whom this video is meant for. So I think high school students, of course, college students. Uh, you might remember that in class 10, there's at the very last there is a chapter on probability and statistics, right? And I think that is a very impactful chapter, which we don't realize the importance of that at that point of time. But if I say there are lots to learn from that chapter, and I have that in my mind when I created this content. Uh, and yes, anyone who wants to learn about this but gets bogged down, yeah, because of too much of maths. So I've tried to simplify those things. And yes, anyone who can point out the mistakes, I am very, very grateful to them. So they're most welcome. So let's proceed further. So when it comes to learning, there are two ways, either I take a book, okay, and read from the scratch, line by line, okay, and there are other things is just uh, come up with some keywords, okay, and think about this. So this is my approach to creating this content. I thought a lot. What are the keywords I should know to get a hang of it? And with that in mind, I have come down to a list of questions before you, and it would be very thankful to you if you can also come up with a question. Okay, so that way I will also learn something. So coming to the first part, that is probability. The first question is the way. What is a random variable? Yeah, what is a variable first of all? Because variable, there is a variable, there is a random variable, then there is a probability distribution, discrete and continuity, different kinds of probability distributions. So these questions, I think these are the building blocks, okay, uh, relevant to probability theory and statistics. Similarly, in statistics, uh, the building questions goes like this. First of all, we need to understand what is a population, what is a sample of a population, estimate, true value. So these are the questions which we look forward to answer to, and I will highly recommend that you also come up with some questions around that, because questioning improves your learning. Okay, so it is important to come up with a question. Let's go ahead. So part one, it is probability. Yeah, let's come to the first question. Variable and random variable. Hmm. So we have heard this name so many times, variable. But yeah, you might not have heard random variable, but let's understand that the variable and random variable. Okay, so again, these are the differences which I have thought of, and I will highly appreciate if you also come up with some differences in your mind. Okay, so let's the first difference I think of is that the variable is like a container. Okay, the variable is like a container. It can contain some data. Now I will emphasize on the data, because what is data? There can be different types of data. Data can be numbers, data can be text, data can be video, data can be sound. Okay, so variable is like a container which contains all these kinds of data. But when it comes to random variable, I think of it as a spitter. Okay, so it has some data and it will just spit it out. Okay, now that I have told you about data, what do I mean by data? I would like to restrict the kind of data we are dealing with. Okay, so for this content I am restricting it to numbers and boolean. By boolean I mean binary variable, like either it will be true or either it will be false, either it will be 0, either it will be 1, either it will be 5 or either it will be 6. So there are only two possibilities, none other than that. So these restrictions applies to both variable and random variable. Now let's come to the third thing. With respect to variable, either we know what is inside that variable or we get to know after solving some equations or some inequalities. Okay, so this is one aspect. But in random variable, we know what all possible kind of data it can spit. Okay, so I know what are the possibilities uh, it has to spit, but actually I don't know. What is important is I don't know what it will spit out. Okay, so that is a major difference between a variable and random variable. Variable contains some data, okay, but random variable spits some data. I know what kind of data random variable has, all the possibilities, but I don't know what it will throw out. So think of it like a machine. Okay, it is a machine, and say it can spit out two number. Okay, like 1 or 2. So I know it will spit out either 1 or 2, but I don't know what it will spit out. So that is what is meant by random variable. Okay, so here it is. Variable is like it is a container which contains some numbers. Say x is equal to 5, or I don't know whether it is x is equal to 5 or 4, but I come to know after solving this equation, x square minus x is equal to 0, and you can see that it satisfies two values, right? X is equal to 0 and x is equal to 1, correct? And for random variable, let's denote it by x. So x denotes the coin toss. When I toss a coin, it will either split the value head or tail or 1 or 2, a binary. So I hope this is clear to you what is the difference between a variable and random variable. So given now that we understand this, let's proceed ahead. Okay, so now what is probability distribution? Okay, so you have to focus on two words here, probability and distribution. Okay, so first of all I want to make it clear that in the first part of this video, that is probability part, I'm not going to tell you how to calculate probability. Okay, uh, I'm not concerned with calculating probability right now. I'm also not concerned about defining probability mathematically or formally. Okay, so it will be just an informal sense of what is probability. So let's say I toss a coin, okay, and I attach a variable to it, say x. So x here denotes the random variable. Now, as I said, I know the values, what it can spit out, but I don't know what actually it will spit out. For here, x can spit out head or say 1, or tail or say 1. But I don't know what it will spit out, whether head will come or tail will come, I don't know. But I am interested in that, right? Whether it will come head or tail, I am interested in that. I am interested in predicting that. So that is more important here. So probability is also like a chance. What is the chance of coming up head? What is the chance of coming that tail? But I am not quantifying here right now, right? For example, I give you a coin and tell you what is the probability that it will come head if you toss it. So all you have is a coin in hand. So right now what you can do as part of your learning is take the coin and think and come up with a method to tell me what is the probability of head. I'm telling you, I'm not going to tell how to quantify. I'm just giving you a coin. Take a coin, do whatever you want to do, and come and tell me what is the probability of head or tail. So here it is known, head, say head comes with a probability of 0.52 and tail comes with a probability of 0.48. So I'm not going to exercise that in this part. I will come to that in the statistics part, but not in the first part. So right now you have to just make a sense of probability, and second comes the distribution. Okay, so what is being distributed here? So that you have to understand what is getting distributed over here. So x is a random variable, it can take two values, it can take head or tail, right? or there is a typo here, 1 or 0. Okay. No, sorry for that. Head denotes 1, tail denotes to 0. So these two values it can take, and plus I know here it will take with probability 0.52 and probability 0.48, right? So I am distributing probability here, so that is important here. So what is being distributed? Probability is distributed to all the possible outcomes. The possible outcomes here is head or tail, and I am distributing 0.52 probability to head and 0.48 probability to tail. So once we know the possible outcomes, and I also know the probability associated with the possible outcome, then we say that the random variable is completely defined, its probability distribution is completely defined, and it is complete in sense. Okay, and if we know this much, I can answer so many questions. Okay, by so many questions, I will come to that in the part of statistics. So what do I mean by that? So for now, to completely define a probability distribution, what you need to know is what possible outcomes are going to be and with what probability. Okay, let's come to another example, that is roll of a dice. Okay, so we all know that when we roll a dice, there are 6 possible outcomes, right? Either it will come to 1, 2, 3, 4, 5, 6, but I don't know what actually it will come, right? So that is the property of a random variable. You know the possible outcomes, but you don't know what it will spit out, right? Again here, this is just an example. I'm distributing the probability, 1 with 0.1, 2 with 0.1, and so on. But you also have to see a thing here that it sums up to 1. The values, the probabilities values sums up to 1. Why? Because I know apart from these 6 outcomes, there are no other outcomes, right? So either this will occur, either this will occur. One of them has to occur, and no outcome is going to be away from this, right? That is the reason that sum has to 1. Either this will occur. For the example of coin toss, either head will come up or tail will come up. I know there are no any other possible outcomes. So the chances or the probability has to sum up to 1. So now I hope you understand what a probability distribution is. So the name itself contains so much of information, so much of definitions, right? All you have to do is understand it. Okay. So when I say a probability distribution, two things come up to your mind. What are the possible outcomes and what are the probabilities distributed to each of the outcome. Okay, let's move ahead. Yeah, sense of discreteness and continuity. Okay, so this is something which comes up in every field. You have to have a sense of discreteness and continuity. So I have put up 2 pictures over here. So you can see, if I tell you pick a pen and move across the blue region without lifting the pen, you can't do this here, right? You take a pen, put on the blue region, and you just can't travel on the blue region without lifting your pen, right? This is a sense of discreteness. While here, you can see, you can just freely move your pen once you put anywhere in this region. You can move in the blue region without coming out of it. So with respect to a random variable, discreteness and continuity is concerned with the kind of values it is taking or it is spitting. Okay, I said right, I am concerned with the possible outcomes. So whether those possible outcomes falls under the category of discreteness or continuity, that is I am concerned about here. For example, when I roll a dice, it can take 6 values, right? You can put any level, any 6 levels, right? I am putting here numbers 1, 2, 3, 4, 5, 6. I know between 1 and 2 nothing is going to come. Okay, so that is the sense of discreteness here. Okay. Second example is temperature of a room. Temperature of room, you know, if for example there is let x be a variable, okay, and it spits out temperature of a room at any randomly chosen time. Okay. So there are 2 random things over here. First, the value the variable can take, and second, the randomly chosen time point itself is a random variable, right? So I don't know at what time I will pick, but time is continuous, you know. So the random variable associated with picking a time is continuous because time is continuous, right? Okay. Similarly, the temperature, the value it will take, it's not like it will only 36 degree and 38 degree and 40 degree. it can choose values in decimal also, right? 36.1, 36.2, whatever. So I hope this is getting clear. What do I mean by discreteness and what do I mean by continuity? Uh, Once I understand this, there comes a question: can I discretize a variable? Okay, so think about it. Can you discretize this? Can you discretize the random variable related to the temperature, which spits out the temperature? Can you discretize it? Can you discretize the random variable associated with the time here? Okay, I'll come back to this at some later part of the video, but I'm leaving this something as food for thought for you. So think about it. It is very important, I tell you, because uh, in one of my job interview, I've asked, not directly asked, but the sub part of the answer was this: you had to discretize the variable. Okay, so that is why it is very important. So think about it. Let's come to the next part. Yeah. So once we understand random variable, once we understand probability distributions, so now we will come one by one a variety of random variable which fits into natural setting, which describes some phenomena. Okay, and why this is called standard? This is standard because this is known to everybody in a very standardized manner. It's not that what I understand in India, somebody else in New York is understanding differently. It's not like that. Okay. So another by standard I am saying here because most of the problems related to data science, okay, fits into that. Okay, people try to make analogies. People love to make analogies, right? Even in news channel, everywhere. So when you argue with somebody, you try to make an analogy. Okay, so similarly in data science also, we try to make an analogy with the data, that this data very resembles this distribution, so I'm going to model this data with this distribution. So that is why it is important to know the standard probability distributions. So in the next lecture we will go through all these distributions. Okay, so I hope this have been fruitful to you. You learned something new, and if you really did, please like and share the video, uh, YouTube channel and LinkedIn page. Thank you so much. Have a nice day.